Hi guys, today we're going to talk about chemical bond formation. Why do atoms join together? We're going to be talking about chemistry throughout the course. Some of this can be kind of heady, so just hang in there. I'll try to make it as clear as possible. When we talk about bond formation, there's lots of reasons that elements get together, but for our purposes, we're going to talk about two forces, the octet rule and electronegativity, all right? So the octet rule is kind of simple. And you guys just did your activity that showed the distribution of electrons in their orbitals. And so the octet rule simply says that atoms they desire to have their outermost orbital shell filled, okay? So, and remember in hydrogen, the outermost shell is the 1s shell, and that in carbon, it's the 2s shell. So it doesn't matter what's happening in the interior shells. It matters what's happening in those exterior shells, and we'll see what happens. So atoms want to have that shell filled. So in the case of like the 1s shell, it gets filled with two electrons. So hydrogen isn't really happy. It only has one electron. Carbon has 4 electrons in its outer shell, but it needs 8 to be filled. So what does it do? Another trend of the periodic table that promotes bond formation is something called electronegativity. And electronegativity is the ability or the relationship that the nucleus has to the electrons. Some atoms really love electrons. Others, not so much. And we could say simply that the octet rule is a prevailing force in giving rise to covalent bond formation, which makes molecules. And then this electronegativity or differences in electronegativity contribute to the formation of ionic bonds. All right. So remember that that electrons are distributed into these shells. There's a bunch of different shells. The 1s shell is the lowest energy shell. It's closest to the nucleus. And as we move further and further out, those orbital shells have higher energies. All right. And of course, we find these electrons in their clouds. They're sort of separated from one another. You can see hydrogen, the most common element here, has just one electron, and it wants to fill that shell, so it makes a bond with other hydrogens very readily to form H2 gas. All right. Here's lead, and lead's atomic number 82. It's got a bunch of electrons, and it's only got 1, 2, 3, 4 electrons inside of my shell. Probably wants to have another 4 at least. We call the electrons in the outermost shell the valence electrons. And of course, you guys had an activity to do on this electron distribution, right? So hopefully you didn't have too much trouble filling out the sheet and making your Lewis dot structures and putting your arrows into the electronic ground state configurations. If you did, send me a text and I'll try to help you out. Well, let's talk about covalent bonds. They form when atoms share electrons, valence electrons specifically, those outer shell electrons. So hydrogen forms H2, where 2 electrons are shared here. And we can, remember in the Lewis dot structure, we use little dots. So you could symbolize hydrogen as H with 2 little dots in it, but you could also symbolize those 2 dots as a line. All right, so when you see a line, that represents 2 shared electrons. So oxygens form bonds, and they don't share 2 electrons, they share 4 electrons. They share 4 electrons. That's right. In fact, oxygens join together to form double bonds. Nitrogens have 3 bonds together. They form what's called the nitrogen-nitrogen triple bond. And then in the case of carbon dioxide, I've got a carbon that's bound to 2 oxygens out here. And here's our Lewis dot representations, right? And then here's another way. This is just sort of a molecular formula. All right. So we can have multiple covalent bonds. On the other hand, ionic bonds are formed when I have a big difference in electronegativity. So covalent is when electrons are shared. Ionic bonds are when electrons are donated or stripped or accepted. Okay. So the classic example for an ionic bond is in the salt, sodium chloride. Remember, sodium was atomic number 11. It's got 1 electron in its outermost shell. And chlorine, atomic number 17, has 7 electrons in its outermost shell. Now, They could share an electron, but there's a problem. In the periodic table, we have this trend called electronegativity, where things are really electronegative right here, and things are not so electronegative back there. All right, so sodium's here, chlorine's here. Chlorine's just going to take an electron from sodium. Now that does something interesting. That causes things to change for sodium, right? So the most electronegative elements are right here, and you can see there that makes fluorine the most electronegative on the table, and that means fluorine will strip electrons from pretty much anybody. And of course, these guys over here on the noble gases are really electronegative as well. So here's sodium, atomic number 11. It's got shells, first 1s shell filled, 2s shell filled. The 3s shell has only one electron out there. And that third shell needs 7 more electrons to be filled. Is it likely for sodium to make 7 bonds? No. Chlorine, on the other hand, has 7 electrons in the outermost shell. Not only that, but it's way over on the left-hand side of the periodic table, and it'll strip an electron from sodium. Okay? And when it strips that electron, it has this unusual electronic setup. Remember, chlorine, atomic number 17, has 17 positively charged protons. When it strips an electron, now it's got 18 negatively charged electrons, and that makes it negatively charged. It's formed an ion, the chloride ion. It has too many electrons. Sodium, on the other hand, starts off with 11. It has 11 protons and 11 electrons, but when that electron gets stolen, now it has 11 positively charged protons, but only 10 negatively charged electrons, and it becomes positively charged. It's called the sodium ion. Sodium ion. It's a cation because it's positively charged. This is an anion because it's negatively charged. And what do we know about opposites? Well, opposites attract. And the basis for the ionic bond is this donation of an electron from sodium to chlorine, making chlorine negative, making sodium positive. And then there's what's called an electrostatic ionic attraction between these two things. And they form a salt, or they form an ionic compound. Okay? And so examples of salts include, sodium chloride or potassium chloride. There's all kinds of salts out there, right? But they also include acids and bases. These are ionic compounds. So here's HCl and NaOH or H2 or hydrochloric acid or sulfuric acid. These guys are all ionic compounds. And I'll give you a heads up if you're confused about which ones are ionic and covalent molecules. So the other way for bonding occurs through these covalent bonds, and that brings us to our buddy water. Okay, now water is made up of H2O. Remember that hydrogens only have 1 electron in their outer shell. All right, oxygen has 6, but it needs 8, so it's missing 2. And so what oxygen does is it shares 2 electrons with this hydrogen and 2 electrons with this hydrogen, and then everybody's happy. At some points, hydrogen has 2 electrons and the oxygen has 8. So that's the basis for the bond in water. And water's unusual. It is a covalently bound molecule, but it also has ionic character. And that's because oxygen is really electronegative. Hydrogen, not so much. And so water is weird. And we'll talk about that next time.